Hello friends, welcome to my YouTube channel. Now we will continue our discussion on Tstransco 2014 AE electrical solutions. So the question on the screen is, the figure 1 shows an accurate equivalent circuit for a photovoltaic cell for the cell is. So generally here they represented a current source. Okay, so photovoltaic cell means it's a source of energy. So source, electrical source. So they are representing it as a current source now. Okay, they are representing it as current source. So generally the ideal current source, how it is, ideal current source, it is a current source at the magnitude I, and it will have a resistance in parallel with it, and this is resistance is ideally infinity. Okay, so when we compare this ideal current source with the circuit of a photovoltaic cell, so we can say that Rp is actually approximately equal to infinity, and we don't bother about RS. So in the given appropriate options, so Rp is greater than RS is the solution for this. Next one, the speed of three-phase induction motor is controlled by varying variable voltage and variable frequency control. As the frequency is reduced, the slip at maximum torque. So generally what we are doing here is we are following V by F control. So this is constant. So constant means as V varies, suppose V increases, F also increases, but this product V by F is remains constant here. Now what will happen? What we want, slip at maximum torque. So slip at maximum torque. So slip at maximum torque is rotor resistance divided by rotor reactance, that is equal to, so R2 divided by, so 2 pi F into L. Here what they are asking, so frequency is reduced. Now the frequency is reduced here. So as the frequency reduces, what about this X2, increase or decreases? It is decreases. So once it decreases means ST max automatically increases. So slip is going to be increases. So that is option 2 is the right answer. Next one, an amplifier has a voltage gain of 120. So let's say it has 120, and it is a 10% distortion. So to reduce distortion, 10% negative feedback. So 10% means beta is a negative feedback. So 10% means it is nothing but 0.1 here. Negative feedback employed. The gain of the amplifier without with the feedback. So gain of the amplifier AF is equal to A divided by 1 plus A beta. So remember friends, negative feedback is used in amplifiers. So amplifiers, the drawback is it reduces the gain, except that all are having advantages. So gain with feedback is equal to 120. By substituting these values in the formula, 120 1 plus 120 into 0.1, it is nothing but 120 divided by 13, it is nothing but 9.23. As I told you that the gain decreases. So from this we can conclude that with using negative feedback, the gain automatically decreases. Earlier it was 120, now it was 9.23. The advantage is we are reducing the distortion here. So that's a advantage of negative feedback. So answer is 3. Next question on the screen is a time-based signal in cathode ray oscilloscope. So in CROs we are using time-based signal as a sawtooth signal. Why? Because so in order to reproduce a waveform on the screen of CRO horizontally, we have to change the cycle of the time-based signal. That means it has to increase linearly like this, and suddenly it has to drop down like this. Again it has to increase linearly. So this type of nature of signal is required. So this is nothing but a sawtooth signal. Okay, so you can say V and time period here. So this is a sawtooth signal is a right answer for this question. Next one, a control system having unit damping factor. So unit damping factor means zeta is 1. So zeta is 1 for critically damped system. So zeta is 0 for undamped system. Okay, so zeta is less than 1 means under damped system, which will produces oscillations. So this is the previous AP Genco question. Okay, so this is eta is equal to Less than 1 means it's a oscillatory in response. So this is a previous question and this is a now. For this bit answer is critically damped response. Next one. So Millman's theorem is equivalent circuit. So they are asking equivalent circuit. So Millman's theorem, what it says, that a voltage sources in series with its resistances are connected in parallel can be represented as a single voltage source in series with a resistance. So like this. So it can be represented as a source in resistance like this. Like that, number of sources are connected like this. It can be represented like this. So by Thevenin's equivalent, is a Thevenin's equivalent. Suppose we can model this Thevenin's equivalent into Norton's equivalent. So Norton's equivalent. So Thevenin's equivalent means voltage source in series with a current source in parallel with resistance. So it can be modeled as both voltage source as well as current source. Next question on the screen is, for the network shown in figure 2, when I is equal to 0, V is equal to 20, and when R is equal to 0, I is equal to 10. If R is equal to 3 ohms, what will be the value of I? So whenever they are giving the box type of structure, assume it as a current, a Thevenin's equivalent or Norton's equivalent. So for simplicity, I am considering this network as a Thevenin's equivalent. Thevenin's equivalent. In Thevenin's equivalent, what we will do, we will take it as a voltage source in series with resistance. So VTH, RTH. So this is the network that I am assumed here. So here we have R and current is I. So when I is equal to 0, that means current is 0 means, so what is the voltage that appears across here is V. So V is 20 at I is equal to 0. That means V is equal to 20, that is equal to VTH. Why? Because no voltage drop exists in the network circuit here. So VTH is equal to 20. Next, what they are asking, so if R is equal to 0, that means you are making a short circuit. So when you are making a short circuit means voltage source in series with RTH, VTH and short circuit here. At that time, what is the current here? I is 10 amps. Now RTH is equal to VTH by I is nothing but 20 divided by 10, that is equal to 2 ohms. So RTH is nothing but, now this case is RTH is 2 ohms here. When R is equal to 3, what is the current? So I is equal to, now we will add these two circuits. I is nothing but VTH divided by RTH plus R. So VTH is 20, RTH is 2 plus how much resistance added? 3 ohms. So 20 by 5, 5 1 ja, 5 4 ja is equal to 4 amps. So this is a 4 amps is the right answer. Next question. In a pure resistive circuit, so pure resistive circuits means let's consider a voltage source like this. So pure resistive circuit, let's say R and V here. In a pure resistive circuit, the average power, so P average is equal to Vrms into Irms. So we know that Vrms or is, it can be written as Vm by root 2. Irms can be represented as Im by root 2. So Vm by root 2 into Im by root 2. So Vm into Im by 2. So maximum peak power is, so peak power is equal to Vm into Im, so that it is a 1/2 of the peak power. So the average power is dash of the peak P max. So this is P max now. So this is the answer. And next one. The next question is, what is the power transferred to the load? The efficiency of the power transfer is. So this is from maximum power transfer theorem. So by using maximum power transfer theorem, you can transfer the maximum power from the source to the load with efficiency of 50% only. So answer is 50%. And next one, the second question, next question also from the maximum power transfer theorem only. So the source impedance ZS is given, that is 6 plus J8 in the circuit shown in figure. The maximum real power is transferred from the transferred to the load impedance when the ZL is. So actually ZS is equal to ZL complex conjugate. So conjugate here. So this is the condition to be satisfied for maximum power transfer theorem for uh, this type of loads. So here ZS is already given. What is ZS? Is nothing but 6 plus J8. What will be the ZL? So ZL is nothing but complex conjugate. No? So 6 minus J8 is the answer. So option 4 is the correct answer. Thank you friends. We will continue our discussion on next sessions. If you like my videos, please subscribe and like my videos and comment. Thank you. Have a nice day.